my dear children. Welcome to our maths class. Hope you all are safe at home. Today we are going to learn our third chapter, factors and multiple. You have learned already some topics in 4th standard. Look at this mind map. These are the topics we are going to learn today. They are factors, multiples, test of divisibility, prime and composite numbers, prime factorization, how to find LCM and HCF, relationship between HCF and LCM. Now let's see what is factors. Factor is a divisor that exactly divides the number. See this multiplication fact. 2 into 3 is 6. This we can write as 2 division fact, that is 6 divided by 2 is equal to 3 and 6 divided by 3 is equal to 2. So we can say 2 and 3 are the factors of 6 because 2 and 3 divide 6 exactly. Now we will check how to find the factors of a number. See this question. Find factors of 18. Using two methods we can find the factors of a number. One is by multiplication, other is by division. When we are checking the multiplication table, we can write 1 into 18 is 18, 2 into 9 is 18, 3 into 6 is 18. The same thing we can write it as a division fact. They are 18 divided by 1 is 18, 18 divided by 2 is 9, 18 divided by 3 is 6. From this we can say 1, 2, 3, 6, 9 and 18 are all factors of 18. Now we will discuss test of divisibility. See how to check a number is divisible by 2 first. The rule is if one's digit is 0, 2, 4, 6 or 8, the number is divisible by 2. See the examples. 2304, 3608, 5640. All three numbers are divisible by 2 because the last digit is 4, 8 and 0 here. Next is divisible by 5. The rule is if one's digit is 0 or 5, then the number is divisible by 5. The examples are here 1635 and 8050. Both the number is having 5 and 0 here. So the numbers are divisible by 5. Next is divisible by 10. How to check it? If one's digit is 0, that is the rule of checking. Examples 1260 and 9840. The last digit is 0 here. So the number is divisible by 10. Next is divisible by 3. How to check? The rule is if sum of the digits is divisible by 3. That means we need to add the digits. The example is here 5136. We have to add all the digits. 5 plus 1 plus 3 plus 6. That is equal to 15 here. We know 15 is divisible by 3 because 5 3s are 15. So the given number is divisible by 3. Next is divisible by 9. How to check? The rule is if sum of the digits is divisible by 9. Here also we need to add the digits. The number is 8145. 8 plus 1 plus 4 plus 5. That is equal to 18. We know 9 2s are 18. So 18 is divisible by 9. So the number is divisible by 9. Now let's see how to check a number is divisible by 4. The rule is here number formed by last two digits is divisible by 4. Then the number is divisible by 4. See this example. 8912. The number formed by last two digit is 12 here. We know 4 3s are 12. So 12 is divisible by 4. So this number is divisible by 4. Next is divisible by 6. The rule is the number is divisible by 2 and 3. See the example here. 5136. The last digit is 6, that is even. So the number is divisible by 2. Now when we adding the digits 5 plus 1 plus 3 plus 6, we will get 15. 15 is divisible by 3. So we can say this number is divisible by 6 because it is divisible by 2 and 3. Suppose children, one number is divisible by 2 but is not divisible by 3. So we can say the number is not divisible by 6 because the number should divisible by 2 and 3. See next is divisible by 8. The rule is number formed by last 3 digits is divisible by 8. See the example here. 7,99,728. The number formed by last 3 digits here 728. We need to check 728 is divisible by 8 or not. How to check it? We can check it by division. You know division, how to do it. 728 by divided by 8. We will get the quotient is 91 and the remainder will be 0. So 728 is divisible by 8. So we can say the bigger number 7,99,728 is divisible by 8. Let's see divisible by 7. The rule is difference between twice the last digit and the number formed by the remaining digit is 0, 7 or multiple of 7. See this example. The number is 5019. Twice the last digit. The last digit is here 9. Twice the last digit means 9 into 2, that is 18. The number formed by the remaining digit, that is 501. So 501 minus 9 into 2, that is 501 minus 18. That is equal to 483. If 483 is divisible by 7, then the number 5019 is divisible by 7. We don't know 483 is divisible by 7 or not. Same rule we can apply for checking the 483 is divisible by 7 or not. The same rule we are going to apply here, that twice the last digit 483, that is 2 into 3. Then the number formed by the remaining digit is 48. 48 minus 2 into 3. 48 minus 6, that is equal to 42. We know 7 6 are 42. That means 42 is divisible by 7. So 483 is divisible by 7. So we can say 5019 is also divisible by 7. Now let's see how to check a number is divisible by 11. The rule is if the difference between the sum of the digits at odd places and even places is 0 or 11 or divisible by 11, then the number is divisible by 11. See the example here. The number is 26,378. Sum of the digits at odd places, that is 2 plus 3 plus 8. We will get 13. Sum of the digits at even places, that is 6 plus 7, that is 13. Now we need to find the difference between this sum, that is 13 minus 13 is 0. So the number is divisible by 11. Children, have you heard about prime and composite numbers? Prime numbers are numbers having only 2 factors. That is 1 and the number itself. It has only 2 factors. Now the composite numbers are the numbers having more than 2 factors. See here, 2, 3, 5, 7, 11, 13 and so on are the prime numbers. And 4, 6, 8, 12, 14, here 10 also there. These are the composite numbers. 1 is neither prime nor composite. 2 is the least prime number. Now let's see what is prime factorization. Prime factorization is a process of writing a composite number as a product of prime numbers. Here we have two methods. That is, first one is division method and the second one is factor tree method. The two methods are division method and factor tree method. See the example 48. We have to write 48 as a product of prime numbers. So we need to divide the number by what? The least prime number. The least prime number we can start. The least prime number is 2. Now we are dividing 48 by 2. We will get the quotient is 24. We will write the quotient is down. Again 24 is an even number. 2 is a factor of 24. Again we are dividing 24 by 2. We will get 12. Then again we are dividing 12 by 2. We will get the quotient is 6. Again we are dividing the 6 by 2. We will get the quotient is 3. 3 is also a prime number. So we can divide 3 by 3 only. So we can divide 3 by 3. We will get the quotient 1. Till we are getting the quotient 1, we need to continue the division. So we can write 48 as 2 into 2 into 2 into 2 into 3. Now, next method is factor tree method. This also a composite number. We need to do factorization with a prime number. Till we are getting all the prime factors, we need to continue the division. So 48 here also we can write 2 into 24. Here 24 is also a composite number. Again we need to factorize with a prime number. 2 into 12. 12 is composite. Again we are doing, that is 2 into 6. 6 is composite. We are continuing the process. We will get 2 into 3. 2 and 3 are prime numbers. Now we can stop the factorization. Here see, I rounded here all the prime factors. Now see what are the prime factors here. 2, 2, 2, 2, 3. So we can write 48 as 2 into 2 into 2 into 2 into 3. This is factor tree method. Now let's see what is highest common factor or HCF. Highest common factor is a highest number that divides each number of a set of 2 or more numbers. We can find HCF by these three methods. First is common factors. Next is prime factorization. The third one is long division method. We will discuss one example using common factors now. First, find the HCF of 15 and 20. Common factors, we have to write the factors of 15 first. We know 1, 3, 5, 15 are the factors of 15. Now we will write factors of 20. 1, 2, 10, 5, 4 and 20 are the factors of 20. Among these factors we need to find what are the common factors. Here 1 is common and 5 is common. So 1 and 5 are the common factors. From this, which is the highest one? 5 is the highest factor. So HCF is 5. Now we will see how to find HCF by prime factorization. We know how to do prime factorization. The first number is 18. We need to divide 18 by 2 first. We will start with the least prime number first. So we can divide 18 by 2, that is 9. Then 9 is divisible by 3. It's not divisible by 2 we know. So we can divide by 3, that is 3 again by 3. Last we will get the quotient 1. We can stop. Now it's 24. Start with 2. 12 2s are 24. Again by 2. 6 2s are 12. 3 2s are 6. Last 3 divided by 3, the quotient will be 1. Next is 60. It's an even number, so we know that is divisible by 2. We'll start with 2 first. 30 2s are 60. Even number, again 2. 15 2s are 30. Now it's a 50. It's not even number. Now we are checking it's divisible by 3. Yes, it's divisible. So this is divided by 3. 5 3s are 15. Then 5 is a prime number. 5 can divide it by 5. That is only possible. So the quotient will be 1. Now we can stop it. Now we are writing this all the numbers as a product of prime factors. 18 is 2 into 3 into 3. Now 24 is 2 into 2 into 2 into 3. Now 60 is 2 into 2 into 3 into 5. Among this we are marking the common factors. What are the common factors? See here 2, here 2, here 2, here. So 2 is common for all the 3 numbers. Now 3 is common for all the 3 numbers. Here 3 is there, but one more 3 is not there here. Here also not there. So just we will write all the common factors. 2 and 3. 1, 2 and 1, 3 is common for all the 3 numbers. So common factors are 2 and 3. Now we will get HCF. HCF is product of the common factors. So 2 into 3 is 6. So the HCF is 6. The HCF of 18, 24 and 60 is 6. Now let's see how to find HCF by long division method. See the example here. HCF of 275 and 525. Here we need to divide the number. The bigger number will be dividend and the smaller will be the divisor. Then we need to divide. So 525 divided by 275. 1 is the quotient. Normal division, like that normal division 275, we will get the remainder is 250. No? So this 250 will be the next divisor and the previous divisor will be the new dividend. Okay? So we need to write like this. Again dividing 275 by 250. 1 will be the quotient. Now we will get the remainder is 25. Now this remainder will be the next divisor and the previous divisor will be the new dividend here. Now 250 divided by 25, we will get 10 as the quotient. 10 to 25 are 250, we will get the remainder is 0. So what is the last divisor? That is the HCF. So here the HCF of 275 and 525 is 25. What is multiple? Multiple is a product of the number with a natural number. That is, see this example. 4 into 1, 4 we know. 4 2s are 8, 4 3s are 12, 4 4s are 16, etc. So we can say 4, 8, 12, 16, etc. are the multiple of 4. Now we will see what is lowest common multiple or LCM. A number is a multiple of 2 or more numbers. We can say that number is a common multiple of those numbers. Among that common multiple, the least number, the smallest number is called LCM. These are the 3 methods to find LCM. The first one is common multiples. The second method is prime factorization. The third one is common division. Now let's see the first method of finding LCM, that is common multiples method. In this, see this example, LCM of 3 and 5, how to find it. See, multiples of 3 we have to write first. We know the tables of 3, so easily we can write the multiples of 3. They are 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, etc. Now we will write multiples of 5. They are 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, etc. Among this, we will find first what are the common multiples. So 15 is common, 30 is common, etc. In this, which one is the lowest one? That is 15. That is the LCM. So LCM of 3 and 5 is 15. Now let's see the second method, prime factorization. How to find LCM by prime factorization. We know how to do the prime factorization. See the example, LCM of 10 and 24. See 10, by prime factorization we can write 2 into 5. Here 24 we can write 2 into 2 into 2 into 3. Now the LCM is product of common factors and uncommon factors. Here 2 is the common factor for 10 and 24. The uncommon factors are 5, 2, 2 and 3. So we need to find the product of this. So LCM is 2 into, that is a common factor, then 5 into 2 into 2 into 3, that are uncommon factors. We will get 120. So LCM is 120 here. Now let's see one more example. LCM of 30, 60 and 15. We need to do the prime factorization. So 30 we can write 2 into 3 into 5, and 60 we can write 2 into 2 into 3 into 5. Now 15 we can write 3 into 5. So LCM we can write product of the common factors and the uncommon factors. The common factors we need to check all the 3 numbers first. In this 3 and 5 are common for these 3 numbers. So first we can write 3 and 5 first. Now we need to check the same time any factor is common for any 2 numbers. Yes, this factor is common for this 30 and 60. We need to consider this also a common factor. Now what is the uncommon factor? This 2 is uncommon factor. When we are finding the product, first we will write the common factor of all the 3 numbers, that is 3 and 5. Then the factor of any 2 numbers, this 2 and the uncommon factor 2. So when we are multiplying, we will get the answer is 60. So the LCM is 60. Now let us discuss the third method of finding LCM. That is common division method. Let's discuss with an example. See the example 1. Find LCM of 20, 25 and 30. We need to write the numbers like this. Now start dividing with the least prime number, which is divisible by at least one number. If one number is not divisible by that prime number, we can write down as it is. First, see, I took 2 here. 2 is the least prime number. So 20 divided by 2 is 10. 25 is not possible to divide. So as it is we can write down. Now 30 divided by 2 is 15. Now 10, 25 and 15 we got. So 5 is the common factor of all the 3 numbers. Now we can take 5. If you are taking 2, it's not wrong. You can take it 2 also, because 10 is divisible by 2. At least one number is there, you can take. Here 15 is there, you can take 3 also. No problem. Here I took 5. So we will get the quotient as 2, 5, 3. Then I took 2. 1 is the quotient. 5 and 3 we can write as it is. Now 5 we can take 1, 1 and 3. Now the last one is 3. We will get all the 3 quotient as 1. Now we can stop the division. So we got the factors. Now we need to multiply all the factors. That is LCM is 2 into 5 into 2 into 5 into 3. That is 300. See the next example. LCM of 12, 32 and 36. All the 3 are even numbers. So we can divide all the 3 number by 2 first. So we will get 6, 16 and 18. Again 3 are even numbers. by 2 we will get 389. Here 3 and 9 are divisible by 3. So we can take 3. 183 are the quotient. Again by 3. 181. Now only 8 is there. So we can divide by 2. 141. Again by 2. 121. Again by 2. We will get all three. The quotients are 111. Now we can stop the division. Now we need to find the LCM by multiplying all the factors. So 2 into 2 into 3 into 3 into 2 into 2 into 2. We will get 288. Now let us discuss the relationship between HCF and LCM. That is, HCF into LCM is product of numbers. Consider these two numbers 12 and 18. First we need to find HCF of 12 and 18. We can take prime factorization. After this we will get 12 is 2 into 2 into 3. 18 is 2 into 3 into 3. So HCF is product of the common factors, that is 2 into 3, that is equal to 6. Now we will find LCM of 12 and 18. Using common division method, we will get LCM is 2 into 3 into 2 into 3, that is 36. Now we can find LCM into HCF, that is 36 into 6, we will get 216. Next is product of the given two numbers, that is 12 into 18, we will get 216. Both are same. So we can say HCF and LCM of two numbers is same as the product of the numbers. Using the relationship between HCF and LCM, we can solve some word problems. See, the question is, product of two numbers are 84,942. HCF is 33. What is the LCM? See, the relationship is LCM into HCF is equal to product of numbers. So, it's given product of numbers and HCF. We need to find the LCM. From this equation, we can write LCM into 33, that is HCF, is equal to 84,942. Therefore, LCM is equal to 84,942 divided by 33. We can do the division like this. We will get the quotient is 2,574. Therefore, the LCM is 2,574. Children, listen. You have an activity. In your textbook, you can see page number 52. There is one activity. That is Eratosthenes sieve method. How to find prime numbers between 1 and 100. You can do it in a chart paper or A4 size sheet. Then you can show to me it in the next interactive session. That's all, children. Thank you.